Hello everybody, this is Farhan from AlgosFromScratch, and I welcome all of you to this amazing YouTube playlist on building DistilBERT model from scratch using PyTorch. So this is the very first video of the playlist, and we are going to start with some basic level of introduction. We are going to discuss the roadmap for the overall playlist, and we are also going to discuss some important points on why one should practice these kind of techniques that we are going to cover in this playlist. There is a prerequisite for this playlist. First of all, I will cover that. So the prerequisite is if you have a little knowledge of how to implement models or how to write code for basic neural networks in PyTorch library, that will be enough. Plus, I would recommend that you must go and learn the OOP concepts in Python, because that is a prerequisite for this playlist. Okay, so PyTorch library, we are going to work with classes and their objects, and so that architecture you must have some idea about that before starting this playlist. Okay, so just this prerequisite for the playlist. And then if you are a student or a researcher or maybe a professional somewhere working in the market, and you've been working on pre-training and fine-tuning models, so this playlist basically is going to be equally important for all of you. Let's just start with the introduction of the transformers architecture. You must be familiar with this architecture, that is the transformers architecture. We have basically two parts in this architecture. This one is the encoder block of the transformers architecture, and this second part is basically, this whole part is the decoder block of the transformers architecture. This transformers architecture has been published by the Google back in 2017 or 2018 around. So this architecture was published in a research paper, Attention is All You Need. Okay, so nowadays in the market we see two main categories of the LLMs. Okay, the first one is representative models. Representative or representation models, you can say. And the second one is generative models. Okay, so these representative models are very good at understanding the text. Okay, and that is because these are based on the encoder part of the transformers. So it means that the encoder block is very good at understanding the text and the context of the text, basically. Okay, so this is not the topic of this playlist to discuss the differences between encoder and decoder block. That I will be doing in a separate video. So just quickly giving you an overview of what kind of models do we have on the basis of these two parts of the transformers architecture. Okay, and then this decoder part is basically, it is based on this generative kind of model that is basically based on the decoder part of the transformers architecture. Okay, so we are going to cover a DistilBERT model in this lecture. That is basically the compressed version of the BERT model, and BERT model was also released by the Google. And this BERT model is based on the encoder part of the transformers. Okay, so DistilBERT is going to be the compressed version, but still, efficient enough to in performance. Okay, so with less number of parameters, it is still efficient enough to compete with the base BERT model. Okay, so we are going to discuss the DistilBERT model, and DistilBERT model is basically based on this encoder part of the transformers architecture. Okay, so with this, let's move on to the next part of the video, and that is about the important points of this playlist. Okay, why one should watch this playlist. These points that I have listed down for you guys is going to give a concrete basics for why one should follow this whole playlist. Okay, so the first point is this knowledge outlives any specific library or API. Okay, so you guys know that there are currently different kind of frameworks in the market, and most of the companies, people, they are using these different frameworks, and but you know what, I've been working in the market, and I know that these frameworks, they are kind of volatile. They don't just stay forever. Okay, you once let's say you were working on some framework, and maybe the next month you have a better version of it. Okay, and that will be totally different, and you will have to understand it from the scratch, all the way from the scratch. Okay, you will have the idea, but you will have to understand the architecture behind that framework. Okay, you will have to understand, you will have to learn the syntax as well. So that is about the frameworks, and basically they change. Okay, but these basic level of fundamental parts of the LLMs, or you can say the model architecture, like attention, normalization, backpropagation, they basically have stayed foundational for years. Okay, so we are going to discuss how we can implement these core modules of any LLM. Okay, so this was the first point. The second point is understanding comes before tool fluency. Okay, so if you have idea of how internally these LLMs work, then you can perform better with the tools. Okay, so let's say and there are many other there are libraries, like let's say we have a library that is mostly used for fine-tuning models, and there are hundreds and thousands of models over there. We will be discussing that, because we will start with that. Okay, that is the Hugging Face library. Okay, so Hugging Face library, there is a class in this Hugging Face library that is auto model for sequence classification. Okay, this auto model for sequence classification API, when we call it, we can literally perform sentiment analysis within 4 to 5 lines of code. Okay, and that is, everything is done by this auto model for classification at the back, and you will have no idea of what basically is happening behind this. Okay, so what you are going to understand in this playlist, how these different kind of frameworks, how they work basically, what the APIs, what these APIs basically use behind the scene, how they manage things, how they execute to perform the task. Right, so we will be disclosing all these black boxes basically. Okay, by writing our own code. Okay, then okay, so let's say if you are a student or a researcher. Okay, let's say that you are a student, okay, of master's degree. So this is going to be a foundational playlist for you. Believe me, this is going to be a foundational playlist for you. I myself am a student of masters in artificial intelligence. Okay, so this is something which will teach you about how to write and train models from scratch, and you will have full control of each and every parameter, and you will not be just calling the one dot fit method and everything will be done for you. No, that is not going to be a case anymore if you watch this playlist. Okay, and then writing the complete training loop from scratch, that is one of the most important parts of this playlist, I would say, because you will understand how basically the data flows in neural networks. Okay, so first of all, it starts with the forward pass, then we calculate the loss on the basis of logits and probabilities. Okay, so we have different kind of loss functions, and we will be using one of them. And then we have backward propagations, that is like calculating the gradients basically for all the trainable parameters. Okay, then we will be discussing the how we can optimize them. So this whole part is basically done by the trainer API in Hugging Face library. We just passed some parameters to the trainer API, and everything is done for us. Okay, our training process starts. Okay, and then it gives us the trained model. So that is not going to be case because we will be writing our own training loops. Okay, and then it is going to be a foundational playlist for your AI research journey. Okay, I really appreciate people who are interested in the in understanding the basic level of any subject, be it computer science, mathematics, and any field. Okay, I just love them. Okay, so you only are able to understand what current researches are being done by understanding the basics of that field. Okay, if you do not have idea of how internally things work, you are not going to participate in any kind of research. Okay, so currently there are different kind of research works going on, like quantization, like memory efficient execution of the models, like llama.cpp, and we have some quantization techniques like LoRa techniques, and we can perform PEFT kind of techniques, that basically is the parameter efficient fine tuning. So all these kind of techniques that currently are going on in the market, you will be able to understand them, you will be able to perform, or you will even be able to contribute to these researches they are going on in the market currently. Okay, so this will be going, this playlist is going to be a foundation for efficient AI research. And if you have heard about the GPU speed up, okay, that is maybe somebody has told you that GPUs are faster than CPUs. But what we are going to do in this playlist, we are going to measure it. Okay, we are going to get the intuition of it. We are going to understand the internal working of GPU, how GPUs basically speed up things. Okay, so this will also give you the hardware intuition, and you will not be then a person who has been told that GPUs are faster than CPUs. Rather, you will be the person who understands it, okay, and who will be telling the internal working of the GPUs and how they work. Okay, then of course, while building this kind of architectures, you are going to encounter many issues. Okay, and while debugging them and resolving those issues, you are going to learn a lot. Okay, so it is literally the actual ML work that we need to do. Okay, and if you are a real data scientist, you want to work within the AI community, and you want to contribute to the artificial intelligence field, then you need to have good understanding, and that is you are going to get with the help of debugging your code and facing some errors and issues while developing these complex architectures. Okay, and then of course, when you are going to write the whole code all the way from start till end, this is going to be very crucial for you in your future, because you will understand the complete life cycle of the models, development of models, and the training of the models. So this is going to be the full ML life cycle playlist for you, and you will learn how we load data, how we tokenize them, how we then convert them to embeddings, and how we pass them, in what sequence we pass the data from our architecture, and how we actually confirm the results, how we evaluate them. Okay, so each and everything you are going to do with your own hands, and that is going to help you a lot. Okay, and then finally, this is something again very important, because like there is a heart of the transformers architecture, and that is the attention mechanism. Okay, and we are going to discuss the formula behind this attention mechanism, that is the self attention. Okay, so we are going to discuss this formula behind this. Okay, so this is just a part of the formula. We are going to discuss the original formula, and the real formula we are going to actually implement it from scratch. Okay, so you will be able to understand how this attention mechanism works internally, and then there are different kind of steps that we perform. After that, we will be doing those steps as well, and we will understand it even better. Okay, so that is all about the important points. Okay, so next we are going to discuss the important the roadmap for this playlist. Okay, this is going to be very important. Okay, so please listen very carefully. First of all, we will be working this will be the first step. Okay, so this is going to be step one. In this first step, we are going to download DistilBERT model using the Hugging Face library, and then we will perform the sentiment analysis with the pre-trained model, and we will be just executing a few steps of fine-tuning on top of that with the help of Hugging Face library. Okay, then comes to the next step, and here at this stage we are going to understand the architecture of the DistilBERT model that we previously loaded to the memory and used it. Okay, so we are going to explore this architecture. We are going to look into the layers of architecture. We are going to look into the forward passes, the functions they are basically working behind the scene. So we are going to explore that. Then we are going to write our own custom classes where we will be basically implementing the DistilBERT kind of architecture with the help of PyTorch. Okay, and here we will be doing all we will be creating the whole architecture from scratch. Okay, we will in this specific part we are going to spend most of the time. Okay, so first of all, in this we are going to start. Okay, there is a very important point to remember. We are going to use the same tokenizer from the Hugging Face. Okay, we are not going to develop the tokenizer that is not going to be, that is not the part of this playlist. Okay, we are going to use the same tokenizer from the previous model, and then we are going to start with the embedding layer. Embedding layer, there are different steps in the embedding layer. We are going to discuss them. Okay, and then we are going to start with the uh, single head attention. Okay, and we will then extend it to multi head attention. Okay, that is where we will be splitting this single head into multi heads. Okay, that is a very important technique in the architecture. Okay, and then in the next phase we are going to develop complete transformer block. Okay, and this transformer block will actually have the this transformer block basically will have the complete architecture. Okay, so one transformer block has multi-head attention layer, then feed forward, and there are adding and normalization steps. So we will discuss all of them in this specific phase. Okay, then finally we are going to stack all of these transformer blocks. Okay, that is because in the DistilBERT model we have six blocks, a stack of six blocks, okay, of transformer blocks. Okay, so we are going to stack them, and then finally we are going to implement the classification head. Okay, so this is going to be our journey. Okay, and with this classification head, then we will be able to classify our text. Okay, then once this is done, we will be having our own our own DistilBERT model. Okay, and then going forward we will be writing our own training loops, and we will be evaluating our model. Okay, and of course we will be training our model from scratch using the sentiment analysis data that we will be downloading from the Hugging Face. And so this is pretty much for this playlist, I guess. By this stage we will have most of our work done. Then we will be doing some saving and then reloading kind of steps, where we will be like saving our model to the saving our pre-trained weights, and then we later on can reload the model, and we can perform our maybe further fine-tuning, or maybe the prediction. Okay, so there are a few important things to notice, that during this complete journey we are going to discuss the in-depth mathematics of how this attention works, So we will discuss, rather we will have some hand calculations on how this attention mechanism works. So we will be performing the matrix multiplication that basically happens behind the architecture, and at each and every level we are going to discuss the in-depth maths behind the task. Okay, so we are not going to just pass through the architecture and just get the results. Okay, that is not what we are going to do. Okay, we are going to understand each and every single part of this architecture. Okay, so this is going to be a lengthy playlist, but it is going to be life-changing playlist for you guys. Okay, so that is all for this lecture from my side. I see you in the next lecture. Till then, bye bye.